Number added to both sides of this equation, we had to use this equation, b divided by 2 to the power of 2. And then since b is 8 right here, then we just plug it in. So it would be 8 by 2. And now b, oh my bad, the b would be negative. Then it would be negative 4 over 2. So that would make it 16. So the answer would be b with 16.
So we got problem number 2, which says multiple choice, how many real roots does the function given by the graph have? So we have a 0 real roots, b 1 real root, c 2 real roots, d 4 real roots.
So as you can see, this parabola doesn't touch the x-axis anywhere, so that means it has 0 real roots.
Okay. You start off by looking at your graph, and you can tell that you're going to need a negative in front of the equation. So that cancels out a and d. After that, you look at your zeros. You get negative 1, 0, 1, and 2. You need to make them equal 0. So for the first one, you're going to put x plus 1, x equals 0, x minus 1, and x minus 2. After that, you make it into an equation. You have the negative that's going to be on the front because of the graph, x plus 1. Then you have your x. Then you have x minus 1. And then x minus 2. And then you have multiplicity 2 for this one. So you get c.
It's a negative cubic function because the highest degree it has is right here. It's a 3 and it's negative. So that means you're looking for a cubic function that starts from the top and goes down to the right. So that's how you know the answer is C. For number 2, you're looking for for 2 you're looking for it's even, it's positive, so you know it's gonna look like, it's gonna be like a quad, what's it called? Alright, so for 2 you're looking for it's even and it's positive, so you know it's gonna be both arrows are gonna be pointing up, and its degree is 6, so it's not gonna be a normal graph. And the only one that fits the graph is B. And for number 3, you're looking for an odd degree that's positive, and A fits the graph because it's an odd degree, and it's not a cubic, so this one has to fit it. And for number 4, you're looking for a negative quadratic because its degree is 4 and it's even, and its y-intercept is -1, and this crosses at -1.
Okay. Hi, my name is Jocelyn. This is quiz number 9, question number 5. And then so today we need to find the third factor for this problem. So the problem that we're giving is 2x cubed plus 13x squared plus 17x minus 12. Since we're already given the factor of x plus 3, we can check that one off. So to start this problem, I like to try each one. So I'll start with synthetic division. So I'll try B, which is x plus 4 equal to 0, which gives us x equals -4, which I will put on this side. And then I'll use the terms 2, 13, 17, and -12. So we're at 2, 13, 17, and -12. Bring down the 2, and that is 4 times 2, which gives -8. 13 plus -8 is 5. Thank you. 5, and then 5 times -4 is -20, which gives -3. -3 times -4 is 12. So So that gives a remainder of 0. And because that does give us a remainder of 0, we can take x plus 4 as another factor.
So for the problem, we're doing x divided by x minus 2, and we're trying to graph it and label our asymptotes. So for vertical asymptote, what we're going to do is divide the two variables x and x, and they both have an exponent of 1, which means that since they're equal to, that means that you'll have to simplify to get the vertical asymptote, which is 1. And for the horizontal asymptote, what you're going to want to do is to plug in, or to make x not equal to 0, and you're going to plug in the bottom equation, which is x minus 2. And then you're going to want to put x minus the negative 2 on the other side, so plus 2 on both sides to isolate the variable, and then x will not be equal to 2, which will be your horizontal asymptote. Then what you're going to want to do now is graph it. So when you alright, so now we're going to want to graph it. So we're going to make a graph, and then we're going to want to, once we make the graph, we're going to draw our asymptotes using a dotted line. We're going to draw them at 1 and 1 for horizontal. Yeah, there you go. 1 for horizontal and then 2 for vertical, which will be like that. And then since the equation is a positive equation, what it's going to do is it's going to go downwards and then, like that. So that the lines will go as close to the horizontal asymptote as possible without touching them. And there you go. There's your graph. I love math.
Okay, so you're going to use long division to solve this. So you're going to write it in the equation. You're going to add a 0x here as well as a 0x squared as a placeholder because it's in the equation. So you're trying to find out how many times 2x squared can go into 4x to the 4th. And it goes into 2x squared, so you're going to put it above here. And you're going to multiply across each time. The 3 times you get it here. So you get 4x to the 4th when you multiply those two. You multiply 2x squared and 0x, you get 0. And 2x squared and 1 is 2x squared. So then you're going to subtract, and then you're going to get 6x cubed right here, and negative 2x squared from this. And then you're going to bring down the 3x, and you're going to find how many times 2x squared goes into 6x cubed, which is 3x, so you're going to write that above here. And then you're going to multiply across 3 times and get your answer here, 6x cubed, 0x squared, and 3x, and you're going to subtract and get negative 2x squared, because everything else cancels. Bring down the negative 1. Find out how many times 2x squared goes into negative 2x squared, which is negative 1. Write it, multiply it, and you get 0, and your answer is 2x squared plus 3x minus 1.
Hi, my name is Giselle, and today we're doing problem 7. We're asked to divide using long division. We're dividing 4x to the power of 4 plus 6x to the power of 3 plus 3x minus 1 by 2x to the power of 2 plus 1.
Alright, so to start this problem, you would have to start in the next column because you can't multiply 2x squared plus 1 with 4x times 4, so you start in the next column. So you would have to multiply with 2x squared, which would equal 4x to the power of 4 plus 2x squared. Since there's no power of 2, there would be a substitute, which would be 0x squared. So when you solve it, it would go 6x to the power of 3 minus 2x squared plus 3x minus 1.
Alright, I'm John Wall, and I will be finishing this problem. Okay, so to finish off this problem, you have to multiply by 3x. Okay, and then multiply it by this, which will give you 6x cubed plus 3x. Okay, and then you simplify it further after that. You cross that out. You end up with negative 2x squared minus 1. Okay, and to finish it off, you have to multiply by negative 1, which will be negative 2x squared minus 1, and you will have a remainder of 0. So their final answer will be Oh yeah, that's the negative one right there. So your final answer would be negative 2x squared. No, positive 2x. My bad. Positive 2x squared plus 3x minus 1.
Hi, my name is Dana.
My name is John.
My name is Johannes.
And we're solving problem number 8. And we're trying to find all the zeros for the polynomial function x to the 4th power minus 6x cubed plus x squared plus 24x plus 16.
So in order to start finding some of the factors for the zeros, you have to use the rational root theorem, which you first find the coefficient of the first factor and the last factor. So for the first factor is 1, and for the last factor is 16. So you put 16 over 1, or at least for the factors. So you have to find what makes 16 and what makes 1. 16, you put 16 times 1, 8 times 2, 4 by 4. And there's only one factor for 1. Since the factor is just 1, we can cancel that out and just leave it with these 4. So you're going to test it out in synthetic division.
Okay. So after finding these numbers, we're going to use synthetic division to solve for x.
So to start this problem, you would have to start in the next column because you can't multiply 2x squared plus 1 with 4x times 4, so you start in the next column. So you would have to multiply with 2x squared, which would equal 4x to the power of 4.
Because there is no, the remainder is 0, it is a factor.
And we're going to put a number and do another factor.
Why do we have remainder? That's not the remainder. Alright, that means the remainder. There's no remainder. If it's just 0, it's not.
Because this also has a remainder of 0, it is a factor. We also tried 2, and it also became a factor.
So now we find now we find the rational root theorem of x third minus 4x squared minus 16x minus 8. 1 and negative 8 are the coefficients for the first factor and the last factor. So we're going to put negative 8 over 1. So from there we can get the last remaining, which is 8, 4, and 2, and 1.
True. Okay. 1.
X equals negative 1, negative 2, 2, and 4.
Write a polynomial function of minimum degree in standard form with real coefficients whose zeros are 2, multiplicity 2, and 3i. So the zeros are 2, and it says multiplicity, so there's 2. Also 3 plus I, and these come in pairs, so there's 2. But it's the opposite. You get that. So then you factor this, you get x squared minus 4x plus 4. Right here, it's x minus 3 plus I. That's x. You distribute the negatives as that, so that becomes negative. It becomes negative. And then you get x squared minus 3x minus ix. So then you get this one, and minus 3x minus 3x plus 9 minus, or plus 3i. So you get these two, ix minus 3i minus I squared.
Oh, really? It's like that? It's like that.
So then you cancel things out. IX, 3i. So you x squared minus 6x. I squared equals negative I, or negative 1. So negative 1 times negative is positive. 9 plus 1 is 10. And you get this one and you FOIL it. So you get x to the 4 minus 6x to the 3rd plus 10x squared negative 4x to the 3rd plus 24x squared minus 40x 4x squared minus 24x plus 40. So then you combine like terms, x to the 4. This and this become negative 10x to the 3rd. Then this one. 24 plus 10 plus 4 x squared. So then negative 24x minus 64x plus 40.
Thank you, class.